All right, so welcome back to another video. In this episode, we want to prove that limit as s approaches 3, s squared is equal to 9. We are interested in epsilon delta definition. All right, so we have been hearing about epsilon delta. Epsilon delta, what is epsilon? Right, epsilon just represents how close we want f of x, which is this s squared right here. Okay, this s squared to be close to the L, which is the limit. Okay, and the delta also represent how close S must be to this value we have right here. Okay, so let's look at it. So for every epsilon, it should be positive, right? There should exist delta also being positive, such that this we have right here, x minus 3, right, should be between the ranges of 0 and it should be less than delta. Okay, whenever this function, the s squared right here minus the limit, is less than epsilon. Okay, so basically we can just choose delta to be 0.00001, but your lecturer might be mad at you. That is why we are interested in showing the proof. Okay, so let's look at it here. So fx here is the s squared. So fs is equal to s squared, and the L is the limit, right? Here. So let's consider that s squared minus 9 should be less than epsilon. So we consider this, right? So consider s squared minus 9. Okay, so when we take that, it means that we're going to have s squared minus 9 right here. We have to manipulate this algebraic expression, right? We can see that this is a difference of two squares, right? So we have this is the same as x minus 3 and x plus 3, right? Now, we have this to be delta that we have right here, but we don't have s plus 3. So we have to use from here, we want to separate the functions, right? So we introduce the inequality sign, right? So we have less than or equal to x minus 3 of this, then x plus 3, right? But here we have this to be delta, right? But we have to be able to control this expression to make sure that this function s plus 3 assume a very little number, very, very small number, as s minus 3 should be less than 1, right? So it should be bounded below. Okay, so we should have s minus 3 should be less than 1. Okay, so it means that this expression has been bounded below. So we have -1, right? Less than x minus 3, less than 1. So we add 3 here, which is going to be minus 1 plus 3, less than x, less than 1 plus 3. Okay, so you have 2 less than x, less than 4. Okay, now we're going to consider this right here. S plus 3 should be equal to this 4 plus 3, and that's equal to 7. And also s plus 3 should be less than 2 plus 3, and that's equal to 5. Okay, but we will consider this, right? We consider this because we bounded this expression below. So we are not interested in the 5. We are interested in the above. Okay, so we come here, we have x minus 3 right, times 7. Okay, and that's equal to 7 delta. So here we choose delta to be equal to epsilon over 7. Now, we have to consider a minimum of 1 and also this value, okay, for delta. So we consider a minimum of 1, and also epsilon over 7. Okay, so with this, we can conclude that this has proven our problem, right? So hence limit as s approaches 3, s squared is equal to 9. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mate, and I'll give you more updates.